So, hello everyone, welcome to IGC. So, let's start today's session. So, we left from where we will start. We were solving questions for 2 degree of freedom systems. So, let's move to questions. Yeah, so this was part of concepts. Yeah, so here we discuss about boundary conditions, all these things. Yeah. Yeah. So I guess we left here, right? Everybody? Okay. So let's start question number 7. Okay. So what it says, guys, read the question. Read the question, what it says. The mode shapes of an undamped 2 degree of freedom systems are given as 105 transpose and 1 minus 0.75 transpose. The corresponding natural frequencies are 0.45 Hz and 1.2471 Hz. The maximum amplitude of the vibration of first degree of freedom due to initial displacement to 1 transpose in mm and 0 initial velocity is. So guys, what's the mode shapes are given here. So mode shapes are given as phi 1, it is given as 1 0.5, and phi 2 is given as 1 minus 0.675. Okay, and they gave omega n1, which is 0.45 hertz. Okay, and they gave omega n2, which is 1.2471 hertz. Okay, now guys, in this question there will be no requirement of all these data to solve this question. What else they have given? They have given initial displacements of masses m1 and m2. So they have given this initial displacement x1 at t equal to 0 and x2 at t equal to 0 as how much they given? They given it as 2 1. Now we know the response of first mass if the system the system is vibrating with combined mode. So what is that? We know x1 is what? X1 for first natural frequency or first mode, cos of omega n1 t plus x1 for second natural frequency, cos of omega n2 t. Right? This is what the response equation. So what they asked? They asked the maximum amplitude of vibration of first degree of freedom. So this is what? First degree. Now when it can be maximum, guys, you know, when it can be maximum, for zero initial velocity, this is what the response for the first degree, right? It is of 2 degrees, so this is for mass 1, right? Now guys, what is the maximum value of cos? Anybody? What is the maximum value of cos? And when it is, what is the maximum value of cos? Anybody? Those who are watching session on YouTube, they can also tell. So what is the maximum value of cos? It is 1, right? So when it is 1 at t equal to 0, right? So what will be your x1 at t equal to 0? It is what? It is 2, the initial displacement, and this is what? X1 for first mode plus x1 for second mode. So what is the maximum amplitude for mass m1 we can have? The maximum amplitude for mass m1 is 2. It cannot be more than 2. Clear? Everybody, it is clear? Okay. So maximum amplitude can be 2. Okay. So 2 is the answer. Now guys, one more thing. Yeah. So 2 is the answer. Okay. Say there are 2 degrees of freedom, right? This x1 and x2. So what they represent? X1 represent first degree and x2 represent second degree. Okay. So 2 will be the maximum amplitude. It cannot be more than that, and it is what? The initial displacement. Okay. So any object which is vibrating freely, okay, you can see, and the initial velocity is 0. What is the maximum amplitude? It is what? The initial displacement. Clear? Okay. So now the next question, read guys what it says. A 2 degree of freedom undamped spring mass system with two masses and two springs has natural frequency omega 1 and omega 2. Again in this question there will be no role of omega 1 and omega 2. The mode shapes for the systems are given by phi 1 and phi 2. If the first mass is displaced by 1 centimeter, the minimum displacement in centimeters to be given to the second mass to make the system vibrates only in first mode. Right? So what is given? Phi 1. So phi 1 is what? 0.7321, and what is phi 2? It is minus 2.731, right? Now guys, we know what is the phi 1. Phi 1 is x1 by x2 for first mode, and it is nothing but what? X1 for first mode by x2 for first mode. Now guys, this system vibrates only in second mode. Okay, so first we write this 0.732 by 1. Same way, what is your x1 for second mode by x2 for second mode equal to, it is minus 2.73 by 1. Clear? Now guys, if system vibrates only in second mode, then what actually we know? Anybody can tell? So we already know what is the initial displacement of mass m1. They mention 1 centimeter, right? This is what the initial displacement of mass m1, right? So at t equal to 0. Now we know what it is equal to. So 1 centimeter will be equal to nothing but we know it is x1 for first plus x1 for second mode. Now they told the system vibrate only in second mode. So what it is? This will be equal to 0. Everybody, yes or no? And what they asked, for what condition, what they asked, what should be the displacement of mass 2? So the system vibrates only in second mode. So that means this x2 at t equal to 0 unknown, and we know it is what? It is x2 for first mode plus x2 for second mode. Yes or no? Now they already told the system vibrates in second mode. So this is 0, right? This is 0. So from this equation, what we found already, we found x1 for first, x1 for second mode is how much? 1. And we already know this. From here, what will be x2 for second mode? What will be the x2 for second mode? See, x1 for second mode is 1. So what will be x2 for second mode? If I write here x2 for second mode, x1 for second mode we know it is 1. So x2 for second mode, from this equation it will be what? It will be 1 upon minus 273. So what it is? What it is, guys? X2 for second mode. Have I written correctly? Transpose is written correctly or it is reverse? First, guys, tell me. Transpose matrix is written correctly or it is reverse? Correct, na? 0.73 to 1 transpose. Is it correct? Everyone, please check. Okay, correct. So, what x2 for second mode? We got minus 0.366. Okay, now guys, we know what is x2. This is what x2. X2 is what? Initial displacement of mass 2. So this is nothing but x2 for second mode. So finally your initial displacement of mass m2. The initial displacement of mass m2, which is what? X2 at t equal to 0 is how much? It is minus 0.366. Clear? Everybody, is it clear? Yes or no? So one thing, this transpose is correct, right? You all have learned mathematics. Okay, that's why I'm asking. So your if your initial displacement of mass M2 is 0.366 and initial displacement of mass M1 is 1 centimeter, then your system will vibrate only in what? Second mode. Oh, sorry. I have done reverse. Guys, wait. They asked the system vibrating only in first mode. Okay. Guys, sorry for that. Okay, the system is vibrating only in first mode. So what we have done, if your system vibrating only in second mode, because we kept this is non-zero, this is non-zero. Okay, so guys, if your system vibrating only in second mode, then answer will be this. Now guys, in given question, what they told your system vibrates, your system is vibrating only in first mode, only in first mode. So what it mean, if you write x1 at t equal to 0, it is nothing but x1 for first mode plus x2 for not x2, x1 for first mode plus x1 for second mode. Now guys, since the system vibrate only in first mode, so this is equal to 0. Same way, your x2 at t equal to 0 is what? X2 for first mode plus x2 for second mode. Now this is 0. Now guys, already we know from this ratio from here, okay, and this is given as what? 1. Initial displacement of mass m1 is given, so we know here x1 for first mode is 1. So from here x2 for first mode will be what? Will be 1 upon 0.732. So tell me what is x2 for first mode is coming. Those who are watching on YouTube, guys, just keep it in mind. They told the system vibrates in first mode alone, but initially we did the solution for if system vibrates in second mode alone. Yeah, so it is how much? 1.366. Now guys, if you see here, this is what the initial displacement or mass M2, and this is nothing but x2 for first mode. So how much it is coming? 1.366. So what is the answer? X2 at t equal to 0 is 1.366 is your answer. Okay, so now guys, understand, if your initial displacement of mass m1 is 1 and for x2 it is 1.366, then your system will vibrate only, your system will vibrate only in what? Only in first mode. Now guys, one technique I will tell you how to cross check whatever we have done is correct or not. How we can check? How we can check, guys? So there is one way. Okay, there is one way to check. I'll just tell you guys what is that way. Once you get these values, right? Once you get this x1 for first mode, x2 for first mode, and so on. So what you guys can do, we already found here, if system vibrates in first mode, we got x1 for first mode was 1, right? And we got x2, not x2, we got x1 for sorry, x2 for first mode as 1.366, correct? Now guys, if you take the ratio, what is your phi 1? Phi 1 is nothing but x1 for first mode upon x2 for first mode. So if you take ratio, what it is? It is 1 upon 1.366. So which is nothing but how much? It is 0.732. It will be 0.732 and 1. Clear? So it should match. Same way, guys, if you write 5.2, your system was vibrating only in second mode. What we got? X1 for second mode was how much? 1. But or let me write here, x1 for second mode upon x2 for second mode. So what was the x1 for second mode? It was 1. And what we got? We got minus 0.366. So if you solve, what you get from here? You'll get minus 2.7321, right? And this is what given. This is what given. Clear, everybody? Any doubt in this question? Any doubt? Anyone have any doubt? Okay, let's move to next question. What it says, the two masses of the 2 degree of freedom system shown in the figure are given initial displacement of 2 centimeter for x1 and 1.24 centimeter for mass 2. The system starts vibrating in first mode. The system is here again vibrating in first mode. The first mode shape of this system is given phi1 equal to 1a transpose. So what is the value of a? So those who are not known to 2 degree of freedom system, I'll write everything. So we know for 2 degree of freedom system with initial velocity 0, or if your system starts from rest, what is your mode, what is your degree of freedoms given by x1 is equal to x1 for first mode cos of omega 1t plus x1 for second mode cos of omega 2t. This is one equation. Second equation is what? x2 for first mode cos of omega 1t plus x2 for second mode cos of omega 2t. Now guys, at t equal to 0, what is your x1? Initial displacement of mass m1. So your x1 at t equal to 0 is initial displacement of mass m1, and so it will be nothing but x1 for first mode plus x1 for second mode. Same way, x2 at t equal to 0 is nothing but x2 for first mode plus x2 for second mode. Now guys, we also know amplitude ratios. So what are the amplitude ratios? It is phi1, which is nothing but what? X1 for first mode upon x2 for first mode. What is your phi2? It is x1 for second mode upon x2 for second mode. So these are the equations you guys should know for 2 degrees of freedom. Now if you look here in this question, what they told, the system vibrates only in first mode. So that means this is 0, this is 0. Only part means the only it is vibrating with omega 1 natural frequency. So this is 0, this is 0. Now guys, in your given question, they told what is x1? The initial displacement of mass m1 is 2. What about this x2? It is 1.24. Now from here, what we are finding, x1 for first mode is coming as 2, x2 for first mode is 1.24. So what will be your phi1? So phi1 will be 2 upon 1.24. So what it is? It is 1 upon 0.62, right? So you can see here phi1 is what? 1. They given it as what? 1a. So what is the value of a? What is the value of a then? It is 0.62. It is how much? 0.62. 0.62. Clear, everyone? Is this clear to everyone? Now, guys, I am asking one question. If they have given your system vibrates, if your system vibrates only in second mode, and they ask to find what is the phi 2. If in case of phi 2, they asked phi 2 and they ask the value of a, so what it will be? We can find in a similar way, right? Okay. Okay, so let's move to next question. I think, yeah. There was one more question from Gate 2020, I think 2021. We will do at the end. One more good question is there from Gate exam. Let me open. Okay. Just a moment, guys. Let me share that question first. I think it is there. Okay. Yeah. So let me share this. Okay, I think so. You guys can see this question. Okay, so this is one of the good question. You guys do it. Okay, I'll let me check if I have my another tab and pen. So read this question. What it says, guys. A 2 degree of freedom spring mass system undergoing free vibration with generalized coordinates x1 and x2 has natural frequencies omega 1 and omega 2 given. respectively. The corresponding mode shapes phi1 is given, phi2 is given. If the system is disturbed with certain deflection and zero initial velocity, which of the following statements are is or are true? So which of the statement is or are true? So the first statement they told, in an initial deflection x1 for mass m1 is given 6.32 centimeter and x2 is given minus 3.16 centimeter, would make the system oscillate with only second natural frequency. Only second natural frequency. So what it mean, this 6.32, the for if we start for option A, so what we find, this 6.32 will be equal to what? System vibrates only in second mode. So let me do on next page. Your 6.32 is equal to what? It is nothing but x1 for first mode plus x1 for second mode. But they told in option 1 the system vibrates only in second mode, so this is 0. So from here what we find, x1 for second mode is 6.32. Now what another condition they told, for mass m2 it is what? Minus 3.16. So minus 3.16, so this is equal to what? X1 for second mode plus sorry, x2 for first mode plus x2 for second mode. Now guys, again this is 0, so from here what we find, x2 for second mode is how much? Minus 3.16. Now guys, if you want find phi 2, what will be your phi 2? It will be x1 for second mode plus x2 for second mode. So from here how much we are getting? 6.32 upon minus 3.16. So how much you are getting, guys? How much you are getting? You'll get minus 2, 1. Am I correct? Yes or no? So, what it is given in the given problem? What is your second mode? It is 1, 3.16, right? But what we are getting? Minus 2, 1, right? So that means option A is not correct. Clear? Because if A is correct, then that means your phi 2 should be not minus 2, 1. It should be how much? It should be 1, 3.16. Clear? A is not correct. Everybody, is it clear? Okay, now let's see for option B. What it says? An initial deflection x1 is 2 centimeter, x2 is given. Now system vibrates only with first natural frequency. Only with first natural frequency. What it mean? What it mean? Now how much it is given for m1 it is 2 and minus 6.32. So what it mean? 2 equal to x1 for first mode plus x1 for second mode, which is 0, and minus 6.32, it is what? X2 for first mode plus x2 for second mode. Now the system vibrates only in second mode, sorry, first mode. So this second part 0. So from here what we see, your x1 for first mode is 2 and your x2 for first mode is minus 6.32. So that means if you find phi 1, what will be your phi 1? It will be x1 for first mode upon x2 for first mode. So from here guys, find out It is 2 upon minus 6.32. So how much we are getting? 1 minus 3.16. So is it correct? This is correct, right? So option B is correct. Okay, option B is correct. Now, if option B is correct, option D cannot be correct, right? Guys, read. If option B is correct, option D cannot be correct. Yes or no? Because again they told the system vibrates only in first natural frequency. So if system vibrates in first natural frequency, that means these cannot be your initial displacement because already B is true. Clear? Everybody, yes or no? Now look for option C. So option C, just reading also we can tell the answer. By reading also we can tell the answer what? An initial deflection x1 is given 2 and x2 is minus 2. And they told would make the system oscillate with a linear combination of first and second natural frequency. Right? So this can be correct. Why this can be correct? Because guys, if system vibrates only with first natural frequency you should get first mode like this. If system vibrates only with second natural frequency you should get this. Okay, so now they given in this problem m1. If you take case 3, how much they gave? M1 initially it is for first mode plus x1 for second mode 2 and it is given minus 2, right? The initial displacement minus 2. Yes. So it is x1 for x2 for first mode plus x2 for second. Now if you look here, if you just check in this case, if system vibrates with first mode, what it happen? This will be 0, this will be 0, right? So in that case also, if you check x1 for first mode upon x2 for first mode, from here what we'll get? We'll get 1 minus 1, which is not true. Now if your system vibrates only in second mode, so that means what we get? We get x1 for second mode upon x2 for second mode will be what? 1 minus 1, which is also not true. So that means system is in combined mode. The system is in combined mode. That is what they have given. So C is the also correct answer. Clear? Everybody, is it clear? Yes or no? Any doubt? See, this was bit lengthy question, but in this way we can solve easily. Everybody, is it clear? Now, guys, if A has to be correct, if A has to be correct, then what should be your given initial displacement? It should be like this. Your x1 should be like 2 and your x2 should be how much? It should be 6.32. Then your A option will be correct. Because if that is the case, then your system will vibrate in second mode. How? It will be like x1 for second mode upon x2 for second mode. If you find from here, what it will be? 2 upon 6.32. So what you get? You get 1 upon 3.16. Clear? When A can be correct if they have given condition like this, or if they have given a what? Initial displacement for x1 it is 1 and initial displacement of x2 as 3.16. So hope it is clear. If not, let me know. If any doubt, guys, please let me know in this question why B and C is correct, not D and A is not correct. Ashish, why D is correct? Option D is wrong, option A is wrong. What is the correct option? B and C is correct option. Okay, so yeah, option C. You want me to tell option C? See, in option C, they have given initial displacement for mass m1 is 2 and for mass m2 is minus 2. And if you use mode shapes and these two equation, you will get all non-zero quantity. You have seen in the previous class, we have solved one question. You remember that question we have solved, guys? This question, I'll just show that question. Yeah, option, the condition C. Now, Sahil, you can see in this case, they have given 1 by 2 and 3 by 2, right? 1 by 2 and 3 by 2, right? 1 by 2 and 3 by 4. What happened? We got linear combination, right? Neither it is in first mode nor in second mode. Clear? So you can see when we got first mode, for this case, when 1 by 2, 1 by 2, we got system vibrating in first mode, right? But when we had 1 by 2 and minus 1 by 2, system was vibrating in second mode, right? The case B, you can see the case B, what it is written, 1 by 2 centimeter downward and upward. So what we got? We got the second mode. And but for option C and D, you can see it's a linear combined mode. C options also and D option also. Clear na, Sahil? So this question, which is in gate question, exactly related to the question which we have done in class. And this is a Grover question. Clear? Any more doubt? If not, we can move to next part, continuous system. Any doubt, guys, who was watching this session on YouTube? Okay, so let's move now to, yeah. Now, guys, tell me, any doubt? Everybody, Pranita, is it clear? Vishal, Advait, Asvis, is it clear? That question is clear from 2 degree MSQ. It came for 2 marks. And if you understand that Grover question correctly, if your system vibrates in first mode, what should be your modes, how it is connected with initial displacement. If your system vibrates in second mode, what will be your mode, how it is connected with initial displacement. Or if your system vibrates in combined mode, you can have any displacement which will not give us what, either first mode or second mode. Clear? If your displacement is given in such a way, if you are neither you are getting first mode or not second mode, then what it is the what is the mode, what is the mode size, what is the mode? If your initial displacement is neither giving you first mode or second mode, then what is the mode? It's a combined mode. Okay, it's a combined mode. Okay, now let's look into this continuous system problems now. So what problem first says, what problem first says, the number of natural frequency of an elastic beam with cantilever boundary condition is. So we know for a continuous system, what is the degrees of freedom? it's infinite. Either it's a cantilever, it is a fixed beam, or it is a shaft, bar, string. Okay, for any continuous system, the natural frequencies are infinite, but because the number of degrees of freedoms are infinite. So D is the answer. D is the answer. I think Ashish, you might have answered for this problem, not for the 2D problem. Okay, I understand now, Ashish. Now read the next question, what it says. The boundary condition for a rod with circular cross section under torsional vibration are changed from fixed free to fixed condition. The fundamental natural frequency of the fixed rod is k times fixed free. The value of k. So guys, we know what is the natural frequency when you have fixed condition for bar or rod. What is the natural frequency when you have fixed condition? It is omega 1, and we found what? Pi by L into C. What is the C? It is under root E by rho. Am I correct? This is what the natural frequency for fixed bar. Now when it is a fixed free, what we got? It is pi by 2L under root E by rho, right? Now what they asked the ratio of fixed by fixed free, right? So fixed natural frequency, they told it is k times of fixed free. So what they told, omega 1 is what? K times of omega 2. Now tell me guys, omega 2 is known, right? So what is the k then? What is the k value? Or you can say omega 1 by omega 2 is k. So with this, what k value is coming? What is the k value is coming? It is 2. Correct. So 2 is the answer. C is the answer. Everybody, it is clear, this question? Okay, so C is the answer. Let's move to next question, what it says. The boundary condition of a rod under longitudinal vibration is changed from fixed to fixed free. The fundamental natural frequency of rod is now k times the original frequency, where k is. So guys, initially it is what? Fixed. Okay, it's changed from fixed to fixed free. Longitudinal vibration means it's a bar and rod. So no, what they told, actually it is initially it is fixed, right? So for fixed we know, right? Omega n1 is how much? Or omega 1. Okay. So for first case, fixed case, how much it is? Pi by L under root E by rho. Now it is what? Change from fixed to fixed free. So it is what? Omega 2. Just a moment, guys. It is pi by 2L under root E by rho. Now what they told, the fundamental natural frequency of rod is now k times the original frequency. So original is what? Omega 1. So what is omega 2 now? Omega 2, they mention k times omega 1. Right? So now tell me, what is the k value? What is the K value? You can see it is K times pi by L under root E by rho. So what is the K? It is 1 by 2. What is the answer? 1 by 2. Clear? Everybody, A is the answer. Okay. So let's move to next question. What it says. Read the question. What it says. The equation of motion of a uniform slender beam of length L in flexural vibration is given by this equation. So we have seen in last class the vibration of beam, okay, where EI is flexural rigidity, W is lateral displacement, rho A is the mass per unit length. The beam is simply support, right? Simply support at x equal to 0 and x equal to L. So it's a simply support, and they assume the mode shape in the fundamental vibration is sine pi x by L. The natural frequency in the fundamental mode with simply support, and guys, we know what is the answer. What was your omega? So omega was what? Pi square by L square under root EI by rho A, right? This is what we got. Sorry, pi by L square, right? Or pi square by L square. Guys, just check and tell what we got. Or we can check by here also, now. Omega, the sine kx, right? So k is coming as how much? Pi by L. And what was the k? K was omega under root omega by c, right? So correct only. It's so pi by L square under root EI by rho A, right? K equal to pi by L, and it is nothing but under root omega by c. So what is omega? Pi square L square into c, and c is what? E by. So what is the answer? What is the answer, guys? Now you can see all the options given and tell me the answer. So B is the answer, right? B is the answer for simply support case. Yeah, B is the answer. Now next question, guys. Is this clear? Everybody, continuous vibration for beam for simply of support, and the first natural frequency is given by pi square by L square under root E I by rho A, because K is what? Pi by L, and which is nothing but under root omega by C. So B is the answer. Next case, read the question what it says. A horizontal cantilevered steel beam of rectangular cross section having width B and depth D is vibrating in the vertical plane. The natural frequency of bending vibration is highest. So guys, a cantilever beam, and it is vibrating in vertical plane, and cross section is given like this. Now tell me, guys, the inertia will be taken about which axis when it is vibrating in vertical plane? If it is vibrating in this vertical plane, you will take inertia about which axis? Suppose this is x and this is y. What will be inertia axis? No, here they are already given z and y. So this is z and this is y. it will be about z axis, right? Because the resistance will be provided by horizontal inertia, right, to vertical deflection. So it will be izz, izz. Now guys, we already know the natural frequency for beam. It is proportional to what? It is proportional to ei by rho a l square. It's always like this. L power 4, not L square. It is, if you take inside under root, it is L power 4. If you take outside days, then it is 1 upon L square into EI by rho. Now guys, for rectangular section, what will be IZZ? What will be IZZ? It's a BDQ by 12, yes or no? What will be the area? What will be area? It is BD, right? Now, if you substitute your inertia and area, what you find? It is 1 by 2 L square. Now, it will be 12 E. Now, guys, B get cancelled D. So, what you get? D square upon rho. Am I correct? Is this correct? Now, guys, in this problem, they are keeping length same. They are keeping material is same. So what is changing? Only cross section is changing, right? Only cross section is changing. Yes or no? In this problem, they are keeping length same, material same. Only cross section is changing, right? So that means your omega is proportional to what? Depth, right? Omega is proportional to D. Yes or no? Assis, clear? Omega is proportional to D. Now tell me what they told. They told when the natural frequency will be highest. Omega is highest when? If D is the highest. So for which case D is highest? Among all four options, which is the case where D is highest? Because your omega doesn't depend on B, it depends only on D. So which case? C is the correct answer. C is the correct answer. So system will be vibrate with the highest natural frequency when your B is 5 and D is 20. Now guys, if they asked when the system will be having the lowest natural frequency, lowest will be for the case of D. Okay. So C is the answer. Okay. So let's do a poll quickly. This is what the area. So let's see next question what it says. The natural frequency of the first mode of a rectangular cross section cantilever aluminum beam is omega. If the material and cross section remain the same, but the length of the beam is doubled, the first mode frequency will become. So guys, we know for again case of the beam, your omega is proportional to 1 upon L square, right? Now what they told, the length is double. What will be your frequency? So we can say omega by omega 2 by omega 1 is what? It is L1 by L2 whole square. So what is the L1 is L, what is L2? It length is becoming double. So what will be the omega 2? What will be the omega 2? Yeah, Swiss. It is omega 1 by 4. Now, if you see 12 is na BDQ by 12. Sorry, it is in denominator. It is in denominator. It's a BDQ by 12. Sorry, it is in denominator. Okay. If you write I by A, it will be D square by 12. I by A is nothing but what? Section modulus, right? Not section modulus, sorry. I by A is not section. I by Y we take section modulus. So I by A is what? D. Anyway, this is just typo, okay? So omega is proportional to D. Guys, just look into that. Okay. So in next question, we can see your natural frequency will become 1 by 4th of initially. So initially it is omega. So it is omega by 4. So what is the answer? A is the answer. Thank you for correcting me. Okay. Thank you. That will be in denominator. Okay. So here A is the answer. Next question, read what it says. The equation of motion of a vibrating rod is given by this. We know that already, governing differential equation for longitudinal vibration. Here U is the displacement along the rod and is a function of both x and t. Find the response of vibrating rod. We need to solve these equations using boundary condition and initial condition. So what is the question they ask? The boundary condition needed for a rod fixed at root and free at tip. So we know at the fixed end u is 0 and for free end dou u by dou x is 0. Now what is the your fixed end? Fixed end is given at x equal to 0, so it will be 0. And where is it free end? So it is dou u by dou x at x equal to L equal to 0. So what is the answer, guys? Which is the correct? So these are the boundary condition. We know this is for fixed end and this is for free end. So what is the answer, guys? Everyone? Yes. Ashish, you are telling B is correct answer for which question? Ashish, can you tell for which question? Sixth or seventh? So for sixth it is A. For seventh it is A. Seventh it is A, na? Why it is B? Why it is B? It is A is the answer. A is the answer. Okay. So A is the answer. Quickly, guys, respond to. We'll wind up. No, not a problem. In few minutes, there are some question more. Okay. Next, the natural frequency for fixed free rod can be obtained using. So we know already, guys, for fixed free case, what was your natural frequency? It was pi by 2 under root E by rho. Pi by 2 pi by 2l under root e by rho. This was the natural frequency and it came from cosine, right? We know this came when if cos of omega c, sorry, omega, not c, omega l by c equal to 0, right? For this condition we got, right, this. So basically when cos is 0, for cos 2n plus 1 by 2, right, into pi. Am I correct? Now guys, if you equate what we see, omega by c into L is what? 2n plus 1 by 2 into pi. And we know for first natural frequency n is 0. So what omega we are getting? We are getting pi by 2l into c. C is nothing but under root e by. So what is the answer? What is the answer for question number 8? So A is the again answer, omega L by C, cos of omega L by C equal to 0. So A is the answer. A is the answer. Right. So questions are not tough if you understand continuous vibration of continuous systems. Questions are based on governing differential equation, boundary condition, and related to natural frequency. So read the question what it says. So this came in GATE 2009, the year in which I wrote the paper. So what it says, the partial differential equation for torsional vibration of a shaft of length L, torsional rigidity Gj, and mass polar moment of inertia per unit length I. So this is what they have given equation where theta is the twist. So we know if both ends are fixed, right? We already know for in case of shaft, vibration of shaft, for fixed end, what is the condition? Theta is 0. And what is the condition for free end? In case of vibration of shaft, dou theta by dou x is 0. Now here they told both ends are fixed. So what is the answer? Theta at x equal to 0 will be 0 and theta at x equal to L will be also 0. So which is the correct answer? What is the correct answer for this question number 9? Mr. Assis, what is the correct answer for question number 9? So those who are watching session on YouTube, they can thumbs up this session. If they are finding this session is useful, they can thumbs up. So B is the correct answer for this. Let's see the next question. Question number 10th. So when we know for fixed case, the nth mode is given by sine n pi x by L, then the nth natural frequency. So this sine n pi x by L is nothing but, guys, equal to what? Sine omega, sine omega by c into x, right? Omega by c into x. So what is omega now? It will be n pi by L into c. So which is the correct answer? Only one answer can be correct here, which is what? A. Because the multiplication of c is what? N pi by L, right? So which is only case where A is the correct answer. Now guys, we can find the c value also. If you see in this problem, Usually what equation, governing equation we write, dou square theta by dou x square will be what, 1 upon c square dou square theta by dou t square. So now guys, from here what will be c square? Now from this equation what is c square? Anybody? What is c square? It is gj by I. Am I correct? Gj by I. Am I correct? So what will be c then? C will be under root gj by I. So you can see here. So what is the answer? Next question. Read the question what it says. The partial differential equation governing free vibration of a uniform Euler-Bernoulli beam is given by this. Okay, where E is the flexural stiffness, M is mass per unit length, and W is what, bending displacement. X is the coordinate along the beam length, T is time, L is the beam length. So we know in case of beam, how many boundary conditions I told in last class. You know what is your Wx by T is given by what? It was what? A sine omega t plus B cos of omega t. Then what? It was C1 sine kx plus C2 cos kx plus C3 sine hyperbolic kx plus C4 cos hyperbolic kx, right? This is the general solution, right? Now tell me how many boundary conditions you require to solve this. Four boundary condition, right? And how many initial condition? See, this is the time dependent and this is what, space dependent. So 4 and 2. So which is correct answer? Which is the correct answer? D is the correct answer. D is the correct answer. Okay. Now, guys, in case of cantilever, what is the boundary condition at x equal to 0? We will be knowing your displacement x is 0 and your displacement, we write it as w, right? Your w will be 0, then dou w by dou x will be 0, right? Your displacement and slope are 0 at fixed end. At free end, what is the boundary condition? We know bending moment will be 0, dou w, dou square, bending moment is what? Dou square w by dou x square 0, as well as shear force dou cube w by dou x cube will be 0. Okay, that these are at free end. So let's move to question number 12. What it says: for the cantilever beam shown in the figure, which of the following cannot be a possible boundary condition? So we have already seen at x equal to 0, yes, displacement is 0. Now what is C is telling? At x equal to 0, your bending moment is what? 0 or non-zero? Your bending moment is not 0, right? At x equal to 0. We know here at x equal to L, bending moment is 0. Yes, correct. At x equal to L, shear force is 0. Yes, correct. So what is the correct answer? C is the correct answer, right? C is the correct answer. Okay, so I think, yeah, one more last good question. Quickly, we need to finish because you guys have another class today. Okay, so let's finish that question also. And anyway, that question is done in mathematics also. Next question is done in math. Okay, but I'll do it. I'll tell you the shortcut method. So this question is already done in math, right? It is done in mathematics, yes or no, guys? Ashish, this is done in math or not? It is done in math, but still this question is also belongs to your mechanical vibration. How? So here, if you write your equation, what it will come? Dou square u by dou x square will be 1 upon 25 dou square u by dou t square. Okay. So guys, then tell me what is the c value? In this case, what is the c value? C will be 5, right? C will be 5. Now guys, we know in case of this rod, what is your generalized equation? U of x comma t will be what? A sine omega t, or sorry, we usually write space coordinate, space first, right? So a sine omega x plus b cos omega x, then c sine omega t plus d cos of omega t. Am I correct? This is what the general solution, yes or no, everybody? Now guys, if you look carefully, given boundary condition, what is the boundary condition given? If you look here, this is dou u by dou t at t equal to 0. What it is? Dou u by dou t at t equal to 0. What it mean? Initial velocity is what? Initial velocity is what, Pranita? 0, right? Whenever initial velocity is 0, what will be the response? Sinusoidal or cosine? Advait, Asvis. In case of vibration, free vibration, whenever initial velocity is 0, your response will be cosine, not sinusoidal, Asvis. It will be cosine. How it is, I will tell you. Suppose your u of t is given as what? It is some amplitude a times cos of omega t. Now initial velocity is 0. You can check it. If you write dou u by dou t, what it will be? It will be a omega minus a omega sine omega t, right? So when it is 0, if the function is cosine, then it will be 0, right? You can check at t equal to 0. Now it will become at t equal to 0, it is 0. Yes or no? Quickly. If for free vibration, if initial velocity is given 0, then your response will be always cosine, not sinusoidal. Okay, so that means this part is 0. Clear? Now guys, if you see this boundary condition, what they told, at x equal to 0, u is 0, and at x equal to 1, again u is 0. What it mean? Anybody tell me what it mean? What it mean? U is 0 at x equal to 0, and u is 0 at x equal to L, right? So it's a fixed end, right? So in case of fixed, what we found in last class, what was the B value? What will be the response? Huh? Space response will be what? It will be sinusoidal. So this will be 0. So with boundary condition, what we already know, your B is 0 and C is 0. So that means your response u of x comma t is nothing but a times d to sine omega x omega by c, right? I think here c it was. The response was what? Sine omega by cx. Okay, so it will be sine omega by cx, then cos of omega t. So this will be your response for this problem. Now in this problem you can see this is the first boundary condition, right? At t equal to 0. So guys, you can substitute in this equation t equal to 0. What you find? U x comma 0. You will get AD sine omega by cx, right? Cos 0 is 1. So from here, this, and if you compare this, what you get? If you compare these two, I will get, this is what, nothing but given as 0.00, not 00, 0.01 sine 10x. So from here what we see, your AD is 0.01 and your omega by C is 10. So from here what is omega? From here omega will be 10C. So 10C means what? It is 50. Everybody, is it clear? Yes or no? Okay. Now guys, it is 10 pi, not just 10. It is 10 pi. So it is 50 pi. It is 10 pi. Okay, so 50 pi. Omega we got. So finally, what is your response? U of x of t will be what? If you write response, it will be 0.01. Then sine of 10 pi x cos of 50 pi t, right? Now what they asked u at 0.25 comma 1. So u at 0.25 comma 1 will be what? It will be 0.01 sine of. Now, what is the x value? X is 0.25. So, what it will become? 0.25 into 10. So, it is 2.5 pi. Then cos of, it is 1. So, it is cos of 50 pi. So, tell me the answer. What is sine 2.5 pi is 1 and cos of 50 pi is 1. So, what is the answer? What is the answer, Mr. Assis? So thank you guys for watching this session, and we have solved all the questions of 2 degree as well as continuous system asked in previous year's papers. Okay, and 2 degree is bit tougher compared to continuous system, and in last 2 years they didn't ask question from continuous system. They asked in last two paper questions from 2D only. So this year you guys can expect question from continuous system, and this was one of the good question number 3 is from continuous system. So it was one of the good simple question, and it is also common with your mathematics for partial differential equation. So what is the answer finally? So we solved this question with the sum of the common sense. So common sense means we know for fixed condition what should be response, space dependent response. For initial velocity, if it is zero, what is the response? So what is the answer side? It's clear, na? Simple. What is the answer? Sine 2.5 pi is 1, cos 50 pi is 1. So what is the answer? Nothing to calculate, Ashish. Here no calculation, direct answer. This is 1, this is 1. So what is the answer? 0.01. Why calculation is required? Cos 50 pi is 1, right? And sine 2.5 pi is 1. So what is the answer? So 0.01, right? There was no calculation involved here. Simple. We have not done any calculation. So everybody, is it clear why 0.01 is the answer? Yeah. So one more update. We are going to start our 2025 batch from Feb 18. So you guys can inform to your juniors and friends if anybody interested for proper right guidance, and you all know your experience with IGC, so be free to share. Okay, so our upcoming batch is starting from Feb 18th for GATE 2025. So thank you all for watching this session, and the answer is clear na, 0.01. Sahil, you got or not? Sri Harsha, Pranita, everybody got 0.01? Okay, done. So, thank you. Okay, so thank you all for watching this session, and for any further support, you guys can contact us on these numbers, and you can visit our websites. So, thank you all. You guys can also refer or follow us on social medias on different platforms.